In this class, we learn about an important topic that is calcium homeostasis. Calcium homeostasis. Before knowing about calcium homeostasis, we learn some things about calcium. Around 1 to 2 kgs of calcium is present in adult. And out of this 1 to 2 kgs, 99% of calcium is present in bone. And uh, 1% of calcium is present in ECF, and this ECF calcium has a metabolic role. In blood, the calcium levels are around 8.5 milligrams per deciliter to 10.5 milligrams per deciliter, and this 8.5 to 10.5 is a very narrow range. And calcium has its metabolic role in neuromuscular functions. It helps in secretion of hormones, and it helps in signal transduction, where calcium can act as a secondary messenger and causes signal transduction. And all these functions are dependent on calcium. Whenever calcium is out of this narrow range, can affect these normal functions. So in order to maintain these functions in a proper way, the calcium has to be maintained in this narrow range only. Out of this range will cause derangement in these metabolic functions. And this total blood calcium is divided into three parts. In the body, it will stay in three forms. First one is 50% of calcium, which will stay in a ionized form, and this ionized form is an active form. And next, 10% of calcium is bound to bicarbonate, lactate, citrate, phosphate. And one more form is there, that is which is around 40%, and it is bound to albumin. And 50% calcium and 10% calcium is a diffusible form, and the 40% which is bound to albumin is non-diffusible one. In relation to albumin, we should know some important things. What happens when albumin is decreased? Whenever albumin is decreased, then calcium will be decreased. That too, protein bound calcium is decreased. Okay, for every gram per deciliter decrease in albumin, it will decrease zero point 0.8 milligrams per deciliter calcium level. Okay, for every gram per deciliter decrease in albumin, there is a decrease of 0.8 milligrams per deciliter calcium. So we have to have a formula to get a proper calcium level in relation to hypoalbuminemia. So the corrected calcium in milligrams per deciliter is equal to, we have to multiply 0.8, because for every gram decrease in albumin, there will be 0.8 decrease in calcium level, and we have to multiply this 0.8 with difference between normal albumin and patient albumin, measured patient albumin value. We have to multiply with this factor, and we have to add measured calcium value, and we'll get a corrected calcium value of the patient. With the decrease in calcium, that is protein bound calcium, does we have any clinical manifestations? No. Calcium deficiency in relation to decreased albumin does not cause clinical manifestations. Why it doesn't cause any clinical manifestation? Because ionized calcium is normal, and this ionized calcium is an active form which causes metabolic functions to function. Okay, that's why we don't see any clinical manifestations with the decrease in calcium levels when albumin is decreased. And we should know about two terms, alkalosis and acidosis. What happens here? Alkalosis causes increases negative charge on protein. With the increase in negative charge on protein, it causes increase binding of calcium. And in acidosis, it decreases negative charge on protein. It decreases binding of calcium to protein. Binding of calcium to protein is decreased in acidosis. We should know about these two conditions also. And because calcium is in a narrow range, this calcium has to be tightly regulated, and this homeostasis is done with the help of three hormones. What are those three hormones? Vitamin D, that is called as calcitriol, and parathyroid hormone, and we have one more hormone, that is calcitriol. And we'll learn about each one in detail. Vitamin D. What will vitamin D do? They will act on three organs. That is, they'll action on intestine. They will have action on bone. They will have action on kidney. Now we'll see each one of this thing in detail. First, action on intestine. What will happen in intestine? How it will increase? How will it will help in absorption of calcium? Vitamin D is an fat soluble vitamin, and this cell membrane is having phospholipids, and nuclear membrane will have phospholipids. Okay, this vitamin D directly crosses cell membrane and enters nuclear membrane and enters inside the cell. So vitamin D directly crosses cell membrane, directly crosses nuclear membrane and enters into the nucleus, and they will act on VDR receptors which are present on the DNA, and this VDR receptors will causes transcription and translation and causes synthesis of a protein called as call binding. And this call binding, it will enhance absorption of calcium in intestine, and it also causes increased transport of calcium into blood from intestine. Okay, these things will occur with the calcium with the help of vitamin D, as it will increase synthesis of calbindin. Whenever vitamin binds with the intestinal cell, it increases calbindin level and it causes increased absorption of calcium from into the intestine, and from intestine it will causes absorption of calcium into the blood. Next, we'll see action on bone. Action on bone. What will happen here? In bone, vitamin D will act on osteoblasts. Vitamin D, it will act on osteoblasts, and it causes increased alkaline phosphatase levels from the osteoblasts. That means it causes increased alkaline phosphatase levels. That means secretions are increased in the osteoblasts. This increased alkaline phosphatase will cause increased local concentration of phosphate, and this phosphate will bind with the calcium and they will form calcium phosphate, and this calcium phosphate is deposited in bone, and it will cause increase in strength of the bone. This deposition is called as mineralization. Okay, that means vitamin D will increase mineralization of bone. This is a normal function which will happen in the body. Suppose when calcium is decreased, calcium is low, then how calcitriol will help in maintaining calcium levels? Along with the PTH, it will cause mobilize, mobilization mobilization of calcium and phosphate from bone. That means they will cause demineralization. So vitamin D have both mineralization and demineralization. That means vitamin D has dual role. Dual role. It can cause mineralization and it can cause demineralization. Demineralization. Next, we'll see what is the action on kidney. Action on kidney. How they will act on kidney. So, normally calcium is mostly absorbed in proximal tubule. Most of the calcium is absorbed in proximal convoluted tubule, thick cortical ascending limb of Henle. So in this calcium is absorbed. Most of the calcium is absorbed. With the absorption of calcium, the lumen will have more negative. That means more negative charge. That means lot of calcium is absorbed in the PCT and thick ascending limb, and the calcium levels will be decreased and the charge will also be decreased. That means whenever the fluid reaches DCT, it will have a negative thing and the calcium has to be absorbed against the concentration gradient, so if calcium has to be absorbed against the concentration gradient, then the process will be an active transport. Calcitriol will act on distal convoluted tubule. So in distal convoluted tubule, it is an active transport. And why this is an active transport? Because absorption of calcium is against concentration gradient. Why this concentration gradient against concentration gradient? Because most of the calcium is absorbed in the PCT and thick ascending limb of loop of Henle. So how this active transport occur? And this active transport is secondary active transport. Secondary active transport. We'll see how this will occur. If you take DCT, okay, this is DCT. This is a basolateral membrane. And this is an apical membrane. This apical membrane is towards lumen, and the fluid enters here, and calcium is present in that fluid, and vitamin D is there. This vitamin D will increase the secretion of a protein called as clothoprotein. This protein is called as a clothoprotein. What clothoprotein will do? It enhances expression of a transporter called as TRPV5. This is TRPV5. Okay, this clothoprotein will increases expression of TRPV5. TRP is transient receptor potential vanilloid family. V stands for vanilloid family, and we have one more TRPV6 that is present in intestine, which helps in absorption of calcium. And calcium is present in the lumen, and this calcium is absorbed into the intestinal, not intestinal cell, it is a distal convoluted tubule cell, into the distal convoluted tubule cell. After absorption into the cell, this calcium will bind with a protein called as calbindin. 28 DK. It is called as calbindin 28 DK. This calcium will bind with this calbindin. Okay. How this calcium is absorbed into the distal convoluted tubule cell? Again is the concentration gradient. Here comes major important protein called as transporter called as sodium potassium ATPase pump. This sodium potassium ATPase will help in transport of calcium from lumen to inside the distal convoluted tubule cell. How this sodium potassium ATPase pump will help? This sodium potassium ATPase pump will cause pumping of sodium from inside the cell to outside the cell. Okay, how many sodiums? 3 sodiums. And it causes pumping of potassium in. Potassium, 2 potassiums are pumped in. 3 sodiums are pumped out, 2 potassiums are pumped in. And this is done with the help of breaking ATP. This is how secondary active transport will occur. This causes loss of sodium ions inside the cell. That means this sodium has to get back into the cell. This is done with the help of another protein called as sodium calcium exchanger. What it will do, sodium calcium exchanger, it will move sodium inside, and it causes movement of this calcium to outside, and we have one more protein called as calcium ATPase pump. This is calcium ATPase pump. With the utilization of energy from ATP and ADP and inorganic phosphate is generated, and this calcium is extruded out with the help of calcium ATPase pump. The absorption of calcium is helped with the help of sodium potassium ATPase pump, sodium calcium exchanger, and calcium ATPase pump. So this absorption of calcium in the distal convoluted tubule is an active transport mechanism, that too secondary active transport mechanism. So ultimately vitamin D helps in absorption of calcium in a complex way. Next we will see one more hormone which helps in absorption of calcium, that is role of parathyroid hormone. This parathyroid hormone will also act on 3 organs, that is they will have action on bone, they will have action on kidney, they will have action on intestine. So first we'll see action on bone. What will happen? Where PTH will act on osteoblasts and they will stimulate osteoblasts. And this action on osteoblasts will increases the expression of RANK receptors. RANKL. What is this RANKL? This is receptor activator for nuclear factor kappa B ligand. Okay, this is RANKL full form. and this RANKL will bind with RANK, RANK, and this binding of RANKL with RANK will stimulate osteoclastic osteoclastic precursors. Osteoclastic precursors. These osteoclastic precursors are monocyte lineage. Monocyte lineage. And they will fuse these cells, these precursor cells will fuse and they form a multinucleated cells. They form multinucleated cells, and these multinucleated cells are called as osteoclast. What is the function of osteoclast? So this PTH helps in synthesis of osteoclast, and this PTH will act on osteoclast and causes activation of phospholipase C on osteoclast. So there will be activation of phospholipase C enzyme, and this causes increased secretion of collagenase, pyrophosphatase, and lactate. These are increased in the these are released from the osteoclast, and these enzymes will act on bone and causes calcium mobilization. That means whenever calcium is decreased, this PTH will act on osteoblast and it increases RANKL receptors expression, and this RANKL will bind with the RANK and causes synthesis of osteoclast. This osteoclast will have phospholipase C enzyme. PTH will stimulate that phospholipase C enzyme and causes secretion of collagenase, pyrophosphatase, and lactate. These will act on bone matrix and causes calcium mobilization. This calcium mobilization will cause loss of bone matrix. That means there will be demineralization of bone. Okay. With the breakage of bone, mucopolysaccharides and hydroxyproline, these two are excreted in urine. Okay, this is how PTH increases whenever calcium levels are low in the body. Next, we'll see action on kidney. PTH, what it will do, it increases calcium absorption by acting on distal convoluted tubule and increases calcium levels. And PTH causes increased excretion of increased excretion of phosphorus, that is phosphate is excreted out, and causes decreased serum phosphate levels, decreased serum phosphate levels. Okay, whenever PTH acts on kidney, it increases absorption of calcium, and it decreases serum calcium level by increased excretion of phosphate. And in kidney, they will activate enzyme 1 alpha hydroxylase. This 1 alpha hydroxylase will help in formation of calcitriol. Calcitriol. Next, action on intestine. Action on intestine. It will PTH increases intestinal absorption of calcium. How it will increases absorption of calcium? PTH increases vitamin D formation. How it will help in vitamin D formation? PTH act on kidney and causes increased activity of 1 alpha hydroxylase. This 1 alpha hydroxylase will increase synthesis of vitamin D, and this vitamin D acts on intestines, and it will cause absorption of calcium by increased formation of calbindin. Increased formation of calbindin. This is how PTH helps in maintenance of calcium level in the body. So this is about PTH, parathyroid hormone. Next, we'll see role of calcitonin. Calcitonin. This calcitonin is released from parafollicular cells of thyroid gland. Whenever calcium levels are increased in the blood, then they will stimulate parafollicular cells and causes release of calcitonin. Okay, this calcitonin will decrease calcium levels. They will decrease serum calcium levels. How will they decrease calcium levels? By decreased absorption in intestines, next they will cause increased excretion of calcium and phosphate through kidney. Third, they will decrease mobilization of calcium. How they will decrease mobilization of calcium? They increases osteoblast activity. They increased osteoblast activity and causes deposition of calcium on the bone. This is how calcium homeostasis will occur. In our body, we'll see two conditions: either increased calcium levels in the body, either decreased calcium levels in the body. So when calcium levels are low, we'll see what will happen in the body. When calcium levels are low, we have parathyroid glands. These parathyroid glands have calcium sensing receptors. These calcium sensing receptors will sense calcium levels. They will sense calcium levels. When calcium levels are low, parathyroid glands are stimulated. They are stimulated. They are stimulated and causes a release of PTH. What PTH will do? It will act on three organs. Three organs. That is on bone. It will cause bone resorption. Bone resorption and releases calcium into blood. In kidney, what they will do? They increases activity of 1-alpha hydroxylase and increases synthesis of calcitriol. They increases calcium absorption in DCT, distal convoluted tubule, and they will increase excretion of phosphate. Excretion of phosphate. And what happens in the intestine? This calcitriol will act on intestine and increases calbindin, and this increased calbindin will increase calcium absorption. Next, vitamin D, how it will help in maintenance of calcium when calcium levels are low. Vitamin D acts on intestine, that is, it will increase absorption. On kidney, it will increase calcium absorption and it increases phosphate absorption also. It is this phosphate absorption is opposite to parathyroid hormone. And on bone, what they will do? They will demineralize bone with the help of PTH. This is how vitamin D and PTH will help in low calcium level. When calcium levels are high, what will happen? Levels are increased. What will happen? It will cause decreased PTH release and increases calcitonin levels. That means PTH release is inhibited. So no PTH, and there will be increased calcitonin levels. This calcitonin increase bone mineralization and increases excretion of calcium. This is how calcium levels are maintained in the body with the help of these three hormones. So this ends the calcium homeostasis. Thank you.